Question number 21. A small block of mass n is kept on a rough inclined surface of inclination theta fixed in a car. The car moves with a uniform velocity. So there is no acceleration because velocity is uniform. Block does not slide on the wedge. The work done by the force of friction on the block in time t will be. So if I make the free body diagram, we'll see this is the block, and because block has a tendency to move in downward, but question says block does not slide, but according to the component of the weight that will act in this direction, mg sin theta. Block has a tendency to slide down, so the direction of force will be this F, and angle of inclination is theta. Now if I consider in time t, because the car moves with uniform velocity v on this direction, so if I take the displacement of this in time t, so that is velocity into time vt. This is. Now I need to calculate the work done by the force of friction. So if I resolve the component of friction force, this is F, so this angle will be theta. So in this direction force of friction is F cos theta, and it is clear from the diagram the angle between the direction of force and displacement is 180, because friction component of friction force will act on the right hand side, but the car will move on left hand side, so angle will be 180. And now I am going to calculate the work done. So this is force into displacement into cos theta. Cos theta is 180, and now you know that because block is at rest, so the value of friction force will be mg sin theta. So first I will write the value of friction force, that is mg sin theta, into the second requirement is displacement, that is v into t. But you have to very careful, मैंने यहाँ पे स्पेस छोड़ा हुआ है, because मुझे जो फोर्स लेना है वो लेना है component of friction force, and you are seeing that F cos theta is there, so there is cos theta. So total force is mg sin theta into cos theta, and displacement is vt. Angle 180 is minus 1. So when I will calculate, we'll get minus mg vt, and we had sin theta into cos theta. So if I multiply it by 2 in numerator and denominator, so we'll get sin theta cos theta, and this is the value of sin 2 theta. So my final value is 1 by 2 mg vt sin 2 theta. So this is the work done by the force of friction on the block in time t minus 1 by 2 mg vt sin 2 theta. So my option number 2 is correct. So let's move on. Question number 22. So if I go for question number 22, a particle is rotating in a vertical circle, connecting it to the end of massless rod of length L. There will be no mass of the rod, and keeping the other end of the rod fixed. The minimum speed of the particle when the rod is horizontal, for which the particle will complete the circle. So if I make the diagram, so now we can take this is the initial situation of the rod, and fixed will be here. This is the particle. As per the question, particle will rotate and reach this point. So if I consider this is my reference point, because I am going to use the law of conservation of mechanical energy, and that is initial kinetic, initial potential, that is equal to final kinetic and final potential, because K1 will represent initial kinetic energy and P1 will represent initial potential energy. Because I am going to take, this is my reference line, so initial potential energy will be 0, and the initial kinetic energy is half mu square if I consider the initial speed is u, and the final kinetic energy will be 0, and the final potential energy, because this particle will travel a height that is equal to length of the rod. So we'll write mgl is the potential energy, and I have the relation half mu square mgl. So mass will cancel out. So if I go only for u, so that is 2gl, and this is the minimum speed of the particle when the rod is horizontal, for which the particle will complete the circle is root 2gl. So my option number 2 is correct. So now I am going to take the question number 23. A point on a body performing pure rotation. This is pure rotation. 10 cm from the axis of rotation of the body. Angular position of the point from reference line is theta 0.5 e to the power 2t, where theta is in radian, t in second. Acceleration of the point at t is equal to 0. So according to the problem, I need to calculate net acceleration. In this situation, this acceleration is given by centripetal acceleration and tangential acceleration. So for the calculation of this radial acceleration, I need to calculate r omega square, and for tangential I need to calculate r into alpha. So how you will calculate omega and alpha? So we'll see. If I differentiate equation number 1 with respect to the time, so we'll get angular velocity omega. So when I differentiate this equation, and I am going to change 0.5 in terms of 1 by 2. So we'll write 1 by 2 e to the power 2t, and when I will differentiate 2t, will get 2. 2 will cancel. I have e to the power 2t, but according to the problem, we can take time t is equal to 0. So when I will place the value of time t is equal to 0, we'll get e to the power 0, and that is equal to 1. So angular speed. So for the calculation of alpha, I need to differentiate again d omega over dt. So when I will differentiate again d over dt e to the power 2t, so we'll get e to the power 2t into 2. When I will take differentiation, according to the problem, I am going to put the value of time e to t is equal to 0, so we'll get only 2. This is angular acceleration 2 radian per second square. Now I am going to use the equation number 2 because I need to calculate acceleration. So value of r omega square is, and now I am going to take this small r as a common, so we'll write r is here, and omega square is 1 square, and the value of r alpha, because r हमने common लिया हुआ है, value of alpha is 2, so when you will square, will get 4. So I have r into root 5, but question में दिया जा रहा है 10 centimeter. So when you will place the value of this r in terms of meter, we'll write 10 upon 100 into root 5. So 10 10 ja 100. So we have root 5 upon 10, and this is the value of acceleration. So we can say my option number 1 is correct. Let's move on question number 24. I am going to take question number 24. The moment of inertia of a ring about its diametric axis about its diametric axis is I. So meaning of that line is moment of inertia about diameter is 1 by 2 mr square. If I consider mass is m and radius is r, and this is equal to I according to the problem. 1 by 2 mr square is equal to I. Now two such rings are welded as shown in the figure. The new moment of inertia about xx dash is. So if I go the moment of inertia xx dash, हम लोग देख रहे कि this is just like a tangent and parallel to the diameter. So we can take this moment of inertia about diameter plus md square, because this is the formula of parallel axis theorem. So when I will place the value id, that is half mr square, and mass, I need to calculate the separation between two axes, because this is along diameter. Separation between these two is d. So d is equal to r, because as I consider the radius of the given ring is r, so this is mr square. So we'll get 3 by 2 mr square. But we have two such rings, and this is the moment of inertia only for one ring. So for the final moment of inertia about xx dash, if I consider this is I dash and this is the final, so we'll multiply it by 2, 3 by 2 mr square, and we know this is the value just equal to I according to the problem, because question में दिया है कि id is equal to 1 by 2 mr square, and you can take this is equal to I. So when I will replace this value, we'll get 6I. So my final answer is option number 1. Let's move on. Question number 25. A cylinder of mass m and radius r is to be raised on two horizontal step. Height h, this h is r by 3. Cylinder is pulled by a rope as shown in figure. Assuming no slipping, the minimum value of force F to raise the cylinder is. So how we will calculate this question? So in general, if I go for the free body diagram, so we'll see. This is the cylinder, and now if I consider this is the center and this is the final picture, ये मेरा सेंटर है, यहाँ से जो फोर्स अप्लाई हुआ है वो है F/2. इस पोजीशन पर सबसे पहले mg विल एक्ट इन डाउनवर्ड डायरेक्शन. अगर ये मुझे r दिया जा रहा है और यहाँ से जो हाइट है दिस इज r/3, so this is also r/3. So if I go only this part, suppose this is C and this is my point A and this is my point B. So if I go for BC part, total radius है r, जिसमें से मुझे यहाँ से लेना है r/3. This is r/3. ये वैल्यू एक बार मैं क्लियर कर लूं कि ये वैल्यू मेरी r/3 है इसके सरकमफ्रेंस के फाइनल तक. तो अगर मैं ए बी कैलकुलेट करना चाहूं तो वी कैन यूज द पाइथागोरस थ्योरम, बिकॉज द वैल्यू ऑफ बी सी इज 2r/3. बिकॉज मैं फुल रेडियस से जब r/3 माइनस करूंगा तो मुझे मिलेगा बी सी इज इक्वल टू 2r/3. सो इफ आई गो फॉर द कैलकुलेशन ऑफ बी ए, BA is BA square. मैं इसको कैलकुलेट कर सकता हूं बाय यूजिंग पाइथागोरस थ्योरम, एंड दिस इज इक्वल टू r स्क्वायर माइनस 2r/3 होल स्क्वायर. सो व्हेन आई विल सॉल्व, विल गेट VA is equal to √5 times of r/3. अब मेरे पास A से B तक का डिस्टेंस है. मैं क्यों कैलकुलेट कर रहा हूं? क्योंकि मैं टॉर्क सॉल्व करना चाहता हूं इस पॉइंट ए के अबाउट, बिकॉज इफ टॉर्क क्रिएटेड बाई एफ बाई 2 is greater than torque created by the weight of the cylinder, and if I compare these two torque, so if torque is created by F by 2 is greater than torque created by the mg, then this cylinder will raised onto the horizontal surface. So now I am going to calculate torque first due to F by 2. So this is the line of action and I need perpendicular distance, because this distance from A, and that is equal to 2r minus r by 3. Only 2r. Because 2r minus r by 3 is the perpendicular distance, because you know if I go from this line of action to the bottom of the cylinder, that is equal to the diameter, that is 2r, and I need only from A, because r by 3 is this. So when you will subtract 2r minus r by 3, will get the perpendicular distance for F by 2. And now I need to calculate perpendicular distance for the weight, because I am going to calculate torque with respect to the point A. So this is the line of action along with the diameter. So perpendicular distance is AB, and AB, as I said, AB is equal to root 5 into r by 3. So this is my final equation. So when you will solve, will get the value of F is greater than 2 times of mg into root 5 divided by 5. So if I multiply it by root 5 on numerator and denominator, root 5 and root 5. So this root 5 will cancel with this 5. So I have the final value 2 upon root 5 into mg, and this is like this. Force is greater than 2 upon root 5 into mg. So we can say my option number 2 is correct.